We're still finding the volume of a shape. We're still looking for the cross section. The only difference is that these shapes are formed by a revolution. This is what a revolution looks like. When I revolve this, it forms a shape. It almost looks like a cone with the tip cut off, or like the head of a bullet or something, because these sides are curved right here. And so how would we be able to find the area of this, or I'm sorry, the volume of this? And in order to do this, we need to know what the cross section is. What is the shape of our cross section?
Circle.
It's a circle. Oh, it's actually a full circle. See, look at that. It's a full circle in there. You guys see that? Okay, now do you know how to find the area of a circle? Okay, so we know how to find the area of a circle, and once you find the function that gives us the area of the circle, you just have to take the integral of it, and then you would find the volume of the whole thing. Here, check this out. This is actually called the disk method. It's called the disk method because our circle in here is solid. There's no like hole in it, and I'll show you guys what the hole means later. I'm trying to find it. There it is. So that's our disk. And so we look at this right here, and we know how to find the area of a circle. Wow, it's a great circle. We find the area of a circle by going pi r squared. But the r changes in our picture. How does the r change? Just look at this picture right here. What is the radius? If I look at what's labeled on here, the radius is gotten or found by taking the x and plugging it into a function that goes up to this y. Do you guys know what function it is that we're plugging the x into? It gives it to you right here. This is why I like this better, because it just kind of gives you the stuff to make your function, to make your formula. So instead of writing r, we're going to put in square root of x, because the square root of x gives you the height from the x-axis up to the end of the circle, and that gives us our radius at any point, actually. So that's why we put x. So our area is pi square root of x squared. I'm going to leave it as square root of x just for visual purposes. Now, the next thing we're supposed to do is we're supposed to plug in all of those x's between a and b. That's our lower bound and our upper bound. That'll give us the area of every single circle and add them together. That's why this integral is a sum. It's an s. So we have the lower bound, which is a. What is our a? Our a is 2 right now. I know that because it says it right here, and you can count right here on our graph. And then the upper bound is 9, which is b. So we're going to plug in all the numbers from 2 all the way to 9. We have pi times the square root of x squared dx. And yes, we can do some simplifying here. It actually makes it look way more simple. We could take that pi and put them outside, and then we have square root of x squared is just x dx, and now we find the integral of this. So we do the antiderivative, we get 1/2 x squared, and then we're going to plug in 2 and 9, and don't forget, we're going to multiply this by pi. After we do that, let's see, let's plug in 9. When I plug in 9, I get 81, and times the 1 over 2, so it's going to be 81 over 2. Then I'm going to subtract. Now I'm going to plug in the 2, so I get 4, and that's going to be over 2, because we're going to take that 4 and multiply it by 1/2. 4 over 2 is just 2. And so now I have, actually, let's leave it with a denominator of 2. Maybe that'll make our lives easier. Now I'm going to multiply everything by pi. All right. Yeah, leaving it with the denominator 2 does make our life easier. We have 81 minus 4, which is 77, divided by 2, and we're multiplying it by pi. That's going to give us our volume. Here, can someone plug that into our calculator so I can get an approximate decimal? Because I know that they give us, what is it? 120.95. All right, let's see our animation here. Our animation will give us, let's see, let's put them all together. Let's show our answer. All right, so once we have all the disks added up together, we get 122.5. Now, what was our answer? 120. You know why it's different? It's because our axis of revolution isn't exactly on 0. And it's really hard for me to get it on 0. It's not moving small enough or whatever. But so this one actually is slightly off because of that, because our axis of revolution isn't exactly on 0.